Today we're going to talk about circles. A circle is defined as the line in which every point is equidistant from a point called a center, and that distance is called the radius. The standard equation of a circle is x squared plus y squared equals r squared, where r is the radius. So in this problem, we're asked to draw our circle. To do that, we're going to start by getting this into the standard form. So standard form has x squared and y squared on the same side. So we're going to begin by adding the x squared over to be with the y squared. And standard form is x squared plus y squared equals r squared. So if our specific equation is x squared plus y squared equals 25, what is r? 5. So we're asked to draw it. So we want to draw a circle with a radius of 5. For our problems today, all of the circles will be centered at the origin. So from the origin, we are going to go 5 in each direction. And connect to make as circular of a thing as you can manage. Mine always look a little bit more like a rounded diamond than a circle. So I'm not going to be picky about your graphs. You don't need to use a compass or anything to make them perfect circles. Just go out 5 from the center in each direction and connect as round as you can. We're going to begin by moving the x squared over to be with the y squared. So x squared plus y squared equals 4. And if our standard form is x squared plus y squared equals r squared, that means we're going to have a radius of 2. So we're going to go 2 in each direction from the center, which will be the origin in today's assignment, and connect around. Questions? The next problem tells us that a point 1, 4 is on a circle, and the center is at the origin. And we want to write the equation of this circle. So the equation of a circle should be x squared plus y squared equals r squared. But we don't know what the radius is, because the radius should go from the center to that point. But we know that the point 1, 4 should make the equation true because it's a point on the circle. So we have a value for x and a value for y that we can plug in. One squared is 1, 4 squared is 16. Adds up to give us 17 is r squared, which we could then solve for the radius, but we actually don't care what the radius is in this question because it didn't ask us what the radius is. It asked us to write the equation of the circle. And the equation of a circle should be x squared plus y squared equals r squared, and r squared is 17. But this does bring up another point on your homework. Our first two questions, the radii, were nice, clean numbers. They will not always necessarily be nice, clean numbers. So if a problem asks you for a radius and it is not a nice, clean number, leave it as a square root, simplify if possible, but give the exact answer. If you need to graph a circle that has a not so clean radius, plug it in the calculator and get a decimal approximation so that you can figure out about where it should be. So if I needed to graph this, if I was given the equation x squared plus y squared equals 17 and I needed to graph that, I would say I have a radius of square root of 17. I don't know exactly what that is, so I'd plug it in my calculator, find out it's a little bit bigger than 4, and then draw a circle with a radius of a little bit bigger than 4. Okay. So if you're graphing, you can get decimal approximations, but if you were asked to solve for a radius, we want it to be the exact value simplified when possible. Okay.
All right, so in this thing when we're solving for, r squared, could we take a square root of the whole problem and say 1 plus 4 equals r?
No, it is not equivalent to take a square root of a sum. Because that would give us, if we took the square root of everything, that would give us 1 plus 4 equals r, and that would give us an r value of 5, which is not true. The r should be the square root of 17. So taking a square root of a sum is not true. Okay. Good question, though, because that's a tempting thing to do. Go ahead and try this next problem. Okay, so we're going to start with our general form of the equation, x squared plus y squared equals r squared. We know a specific x and y that should work because we're told that point is on the circle, so we're going to plug in those values. Be very careful when you plug in a negative, because what is negative 4 squared? Positive 4. If you plug it in your calculator and you do not use parentheses, you will get a wrong answer. Without typing in parentheses, your calculator will tell you that negative 4 squared is, or negative 2 squared is negative 4. Okay, those parentheses make a big difference. So make sure when you square a negative that you're always getting a positive value. Add that up, that gives 29. So our equation then is x squared plus y squared equals 29. Questions? One more type of problem. This one asks us to write an equation of a line. So that's like we did in lesson 1, where we're going to think about y equals mx plus b. And we want that line to be tangent to this given circle at a given point. So we'll draw a picture of what's happening here. I've got a circle that has the point 2, 3 on it. And what I want to do is find an equation of a tangent line. So somebody remind me from geometry what a tangent line is.
Is it a line that only touches the circle in one point, is perpendicular to the radius?
Perfect. Those are both very important facts. So it touches the circle in just one exact point. It doesn't go through the circle. And the key for solving this problem is going to be the fact that in geometry we have a theorem that tells us that a tangent is perpendicular to the radius. So to write an equation of a line, we're going to use y equals mx plus b. M is a slope, and b is the y-intercept value. We know a point that our line goes through is 2, 3, but we need a slope for that purple line. So to find the slope, we're going to begin by finding the slope of that green radius. Slope is rise over run. So what's rise over run there? 3 over 2. It went up 3 and over 2 to get from the center to that point. But if our line, the tangent line, is supposed to be perpendicular to that, negative 2/3. We talked about in lesson 1 again as a reminder that perpendicular means opposite, so positive, negative change, and reciprocal, so flip it over. So now we are going to use that perpendicular slope and the point that we're given as our x and y and plug that into y equals mx plus b. So 3 equals negative 2/3 times 2 plus b. And we're going to solve for that b value for the intercept. So 2 times negative 2/3 gives negative 4/3. I'm going to add 4/3 to both sides. 4/3 is 1 1/3, so 3 plus 1 1/3 is 4 1/3. Or you could leave it as an improper fraction if you wanted and get some common denominators. But our final there is going to use our b value in that perpendicular slope value to write an equation of a line y equals m plugged in plus b plugged in. So these are similar to the problems that we looked at in lesson 1 where we're looking for a perpendicular bisector. So we're still using that idea of perpendicular slope, but this is a little bit quicker because we don't have to find any midpoints or something. Let's try the next one together as well. So you don't have to draw the picture, but I'm a visual person, so it kind of helps me to just see what's going on. So I have a circle that I know goes through the point 1, 4, and I want to make a line that's going to brush the circle hitting just at that point. And that will have to be perpendicular to that radius. So the first thing I want to do is say, what is the slope of that radius? Rise over run. 4 over 1. From the center to that point on the circle, we go up 4 units and over 1 unit. Which means that if we want to be tangent or perpendicular to that, our slope should be negative 1/4. Then we're going to use that perpendicular slope and the point that we must go through as our x and y and plug into y equals mx plus b. So y is 4, m is negative 1/4, x is 1, and we're going to solve for b. So I'm going to add a 1/4 to both sides. You get 4 and 1/4 is b. So our final answer uses the b and that perpendicular m to write our line y equals mx plus b. Questions? On your homework tonight, make sure you read your directions carefully so that you do everything you need to do and you don't do more than you need to do. And it is also important to note that on one section of the homework, there's some built-in review. It asks you to graph the conic section, which could be a parabola or a circle. How can you tell from the equation whether it's going to be a parabola or a circle? In a circle, x and y are both squared. In a parabola, only one of them will be squared. So if the equation has only x or y squared, that's a parabola. So to graph that, you're going to want to look back to your notes from last night and use that chart. And remember, you can feel free to use that chart as much as you want without having to memorize it. So use that chart from last night in the group of questions that has some built-in review. We're going to keep having built-in review through the next lessons, and that'll make it so that when we get to the end of the chapter, the actual review before the test won't be as big of a deal.